Yeah, because there's also okay, you can if you put like example you can get the regular sheet like this. Example if you just do it will go back and you check. This one don't bring the items. Oh. Yes, using your cash. Why? Not cash. After selection, you 200. So that So you pay me and but I you always invent. So it's your money. Bank number. It's branch. Routing number. You know, it's like a picture and it was like walking. Why is it was so that's why I came up there. What you can see? I attended the class. Pregnancy. I was pretending to be, but I was. You know, different generation. She was listening. I just read it. Okay, good. I can send you another thing. You. Oh, yesterday we was like, no, I don't trust each other. I did this 1 hour for you. I'm going to what's the thing? I can't choose my picture. Yeah, you can say. And you can say, that's okay. Okay, because it's now I say. If you know. Tercera vez que lo hice. Entonces, primera vez que vi, no, estaba. Más, plata. Yeah, no, no, esse é, não, é uma boa, não, é a sua, não, quando fica ninguém, entendeu? Mas é que você deve falar, eu acho que é importante postar. Isso, ok, isso você está comigo. Homem, é isso mesmo. Quando mostrar que eu respeitar tudo isso. Foi, eu tenho mais aqui, toda hora, conversar com ele. Sim, é isso, é muito bom. Homem, uma vez assim, é bom, you never know, it's not me. Então, fome é. Eu sou muito falar, não, eu sou é, a pessoa tem muito agora, você não fica você pode se homem seja dele, mas conserta ser seu pessoal. Não, eu vou superar. Eu estou me falando. Eu não vou. Eu só vou fazer. Só vou fazer. Eu vou passar. Ah, é sim, porque eu quero mais. Desculpa. Nossa. Se eu tinha uma na deve ser. Esse é não desse ser um sim. Saudade, saudade. Você pode dizer. Quando isso, pode por aí, por uma programação, nossa, por aí. Por exemplo, os vários design, você pode misturar as quatro, você design. Uma questão de se casar, sabe? Ele tem por ele também homens, você está. não vou comentar mais. Se você tiver o olho, pode conversar. Se você me falou falar, ei, eles são ou eu não vou te falar apoio. Sim, é sério. Você nunca vai ensinar. From one it's you are changing. Why don't we use your past? It's your mind. Okay, so those 100 eu não posso nem conversar com você. Tá passando aí? Sim, tá. Esse é muito show. Yeah, you cannot be different. You can't understand. You start this life. Aqui todo mundo mais comprou. You know what's happening now? Let's send the money to. Yeah, ask.
What? Last one? Yeah, start.
Yeah, money saved. Too much.
But no. Oh, one is missing. First again.
Yeah, you want to do something.
Okay. Capital discussion. So, which of the following different are closed loop system? Refrigerator. Air conditioner.
No, only this one. No. You can say also.
Situation of.
You can.
Oh, maybe there are different types of funds.
Yeah. No.
But this one, if I just add, maybe this figure doesn't show clearly. Oh yeah, that's different buttons means the different level. How fast this fan goes.
Yeah.
And one, two, three, different level. And situation is similar with that of the toaster. And if you press the button, it shows the level and the fan well goes according to the level it goes.
Yes.
And but if you're not satisfied with the speed, but exactly it cannot automatically changes itself. If it can automatically change the speed of the fan, it becomes like the closed loop because it has feedback. But this like this type of just several buttons. Levels are set so change and there is no feedback. So this type of fan is open loop.
Yeah,
Maybe we have more like modal fan and more and the TV, of course. Oh, of course, there are different types of TV nowadays. But for this one, just button, open, and press the button.
change.
Yeah, so it's not the one, it's just manually controlled. Because the television cannot really rewind. Oh, I want to turn to channel. Well, automatically change for you, cannot do that. So this is open. And how about air conditioning? Close, of course. Okay. You see, this one you set the desired temperature 23, and now actually now it is not working. Why? Because the temperature already meets the desired, so it stops. It rests. And when the temperature here goes up or down, this become working. Yeah, to change the temperature here.
Mine never when I said.
Why?
Put like a 18 with 18 and zero.
Yeah, this is air conditioning. So of course it's half that, right? So it's cold flow. And how about refrigerator? Same situation with air conditioning, right? And it will, I don't know, in your annual form, the refrigerator has the, you can set a value for the up and above command. And so once the temperature changes, like you open the door of the refrigerator, maybe the temperature goes higher and the refrigerator keeps working to keep the temperature at the desired. So of course, this one's what? This one's what? Close loop. And besides this word, can you name some other things or instruments that you think is close loop open? Can you give me examples? Lots of things happen occasionally. Can you imagine one?
Washing machine.
Washing machine what? Close or good? Close or depends, right? Depends. If it's a very old type, maybe you just can't set the time. How much time is wrong, so it's just but maybe it's more like it's the washing machine can do the whole process automatically. It's a better process for you. And huh?
What are the
What
What are the Water.
what
Dispense.
dispenser? What dispenser?
What water you drink? What?
That. Yeah. So the desired temperature of the water is like boiling. Yeah. And when it's boiling and the heating process. And yeah. And what? And besides these two, and what?
It's like
It's like it's that. Of course, the press button. Turn on, turn off, and the most easiest to the system.
how about this one? This one almost
And a heater. Heater for what? Here, more let's see. Selling because it just sell the different levels. You want it how long it's getting work, how warm it's getting. So once it's the temperature of the temperature change to what application itself to different states. So application of control theory in mathematics engineering system. It's what we want after learning this course. We can do to apply the theory you learned this course into the real mechanical problems. So the first use of automatic control in Western civilization dated back to the period of 300 BC. In modern time, the theory of control is applied in many fields. Let's see. The theory of control are employed by medical personnel, financial experts, political scientists, biologists, and engineers, etc. So not just engineers, it's in many fields, almost all the fields. And within the field of mechanical engineering, what our major is, the heating system and water heater in a house, or the heating, ventilation, and air conditioning system in a modern building, and for automatic control, which is what we see before, right? And in aerospace, the control of aircraft, helicopters, flights, and the vessels require very complicated advanced control. This is their in ship building industries, advanced control system often employ work theory and navigation. This is a branch of what we use to control theory. So we still have chance, so we will learn some history about the control. So the early control from 1400 BC to 1980. So this is a virtual clock of Western Han, China, Han Dynasty. And it's about 200 BC. And its purpose keeps the water velocity of the water drop to time accuracy. So here's the drop. So the water drop keeps leaking from the drop, one drop, two drop, and in very slow velocity. So you can count how much drops it drops. Then by 10 drops, what time it is, and 100 drops. So this is the very early age. People use this to know exactly the time, to tell what is time now, or to count for the seconds or hours, maybe not in this or week. And this is the very early age. So here we can see a video. Agent time measuring instruments.
Our clocks work so well, we completely take them for granted. It took more than 3,000 years. Egyptian priests, Galileo, and even Chester A. Parker, all working together to synchronize the world. But they did. And now you can feel this. You should go back for seconds. If you're listening to the time, check out this video about the history of the medium. Might make even less sense than why there's 60 seconds.
So it's very interesting way to know how to count the time as the time goes. And nowadays, the most intelligent clock is automated clock, right? Because it's used in aerospace engineering mostly. And we seldom see we use that kind of instrument in daily life. It's cost lots. So this is what we talked before. Centrifugal flywheel England, 1780. So its purpose, control steam valve by flywheel governor in order to keep constant velocity of the engine. Why it is so important? No matter in the I teach this course, control engineering, no matter in your class or in the Chinese students class, this is the example I must teach. Why? Because this engine regulation system is considered to be the first automatically control system in engineering. So this is a symbol. And the pre-classical period is from 1900 to 1935. Automotive components assembly lines invented by Paul Auto. 1930, its feature adopted conveyor belts during producing process. Though we take it for granted nowadays, because we did a lot, no matter what the factor is, it should have the adopted conveyor belts. But it's just already easier. 1030 change from idle production mode to automotive assembly lines. So we will have a video clips here to show automobile and the second industrial revolution.
Historians looked at a bunch of changes in technical systems and called it the Industrial Revolution. But historians love to debate each other, so some of them pointed out the first half of this revolution looks a lot different from the second. Basically, the first Industrial Revolution ramped up around 1800. It started in Britain, ran on steam trains and factories, and led to lots of scientific discoveries by individual researchers such as Volta, Faraday, and Maxwell. The second Industrial Revolution resulted from the industrialization of electricity and mass manufacturing. It happened around 1800. It started in the United States and ran on electricity, cars, and communication technologies. And it led to technological inventions owned by corporations, such as the various Edison companies, and everyone's favorite Orwellian corporate work camp, Ford Motor. Whatever terms you use, the world at the end of the 19th century looked very different than it did at the beginning. For one, lots of people could now see at night because of electricity. For two, the scale of industry and also what that word even meant and changed. For example, German-American engineer John Augustus Roebling lobbied for the 486-meter-long Brooklyn Bridge connecting Manhattan to Long Island. His son, Washington, oversaw construction until 1870. He was seriously injured. Then Washington's wife and co-chief engineer Emily Roebling oversaw construction through the bridge's completion in 1883. Meanwhile, in Paris, the wrought iron Eiffel Tower, completed in 1889, created a metaphorical bridge into the future, and a literal bridge sent nowhere. It's not a bridge. It created one of the most iconic, scale-shifting 19th century American inventions was the automobile. And the new, more efficient factory system that created it. Carl Benz invented the practical automobile in 1885, but cars in the late 1800s were super expensive, so most people moved around on ships or trains between cities and on horses within them. There was this one big problem, biology. Horses got sick, they died, they got into accidents causing traffic jams. Plus, cities couldn't figure out how to clear away all of the manure of accidents. In fact, New York City hosted the first professional conference on urban planning in 1898, and the theme was forest management, which probably was a responsible job. As the saying I just made up goes, it's better to manage than to shovel. Anyway, people love the idea of cars. Better. Henry Ford, a famous inventor who modeled his life on innocence, a progressive vegetarian who helped invent social welfare, a racist who helped invent social engineering, inspiring and all. Ford's legacy is complicated. Ford was raised in Michigan and in 1879 became a machinist. Then in 1891, Ford joined the Edison Illuminating Company in Detroit. He became chief engineer only 2 years later, working on the side on experimental projects such as the quadricycle, which is, why is that not a thing I can buy? Ford loved Edison, the company and the man. He's got Edison's corporate research on lights, photographs, and movies in New Jersey and thought, yes, good, I'm going to do that, but bigger for cars. So in 1903, Ford co-founded the Ford Motor Company. When Ford got started, there were many small auto companies trying out gas, electric, and even steam-powered cars. In fact, electric cars were popular. But all of these cars were still expensive and unreliable, and there were no standard car parts. Ford set out to change all of that. In the early years, Ford Motor was a small-scale operation that carried out mostly experimental work. They had no uniform process for manufacturing cars. Ford's team learned a lot and drummed up a lot of public interest. The Ford 999, for example, broke the lane speed record, covering a mile in only 30 seconds. But Ford wanted a car that was affordable, easy to operate, and tough. He pushed his team, and in 1908, they released the Model T, and this car changed the world. In the first month, only 11 Model Ts were produced, but 2 years later, in 1910, Ford produced 10,000. In 1914, the year the First World War broke out, the company shipped 250,000. And in 1916, Ford sold nearly 500,000 cars, each for less than half the 1914 price. Then in 1927, Ford produced 15 million cars, plus tractors and lots of other machines. These large production numbers highlight the phrase most often associated with Ford, mass production. This style of production meant specialization and standardization. The Ford plants in Highland Park and River Rouge only produced one thing: the Model T. These plants used Ford's special business technique, the assembly line, so they could assemble a car from raw materials in only 28 hours. Using sheet metal, they could assemble a Model T in 1 hour without robots or computers. You can even visit and see this happen because Ford loved watching people experience how this car is being designed. So it succeeded thanks to unskilled labor and a modular system that anyone could learn a single part. That was the core idea of his assembly line philosophy. Fordism. Build sophistication into the product, making it modular using standardized parts, and take skill out of the work involved. Just weld some parts and presto, you're ready to zoom past some horses and put all those food managers out of business. Ford built Model Ts with his version of a small town American utopia. Now, country doctors and lawyers could drive around just like rich British and German Jews. He also hoped that it would keep farmers on the farm, well, white farmers anyway, and he wanted to spur an entire industry of small-scale entrepreneurs who could augment and repair his cars. He even published a Model T repair catalog to help them. The irony was that with his growing company, Ford Motor created an environment hostile to small automobile entrepreneurs. It was expensive to invest in an assembly line factory. And Ford had a problem. Working on an assembly line was awfully boring, so he faced a 300% turnover. He also had $27 million in cold profits that he could reinvest. So he came up with a solution. Double his workers' pay to a whopping $5 per day. This sounded great. In fact, it caused riots when it was announced as people tried to get these amazing jobs. In reality, only white men were even eligible to earn the whole $5. African Americans earned 20% less, and women were mostly ineligible. But Ford worried that simply paying people more wasn't enough. He wanted to educate his workers to become model citizens. So he stipulated that they could earn his new wage only if they met certain conditions. 1, they had to work for 6 months. 2, they had to be clean living, sober, thrifty, and possessed of good moral habits and involved in civic life. And 3, they had to swear off all involvement with union activity. Ford even went so far as to set up the Ford Sociological Department, which conducted inspections of his workers. In his mind, he wasn't just producing cars. He was producing Americans. The sociological department had images of what a worker's house was supposed to look like. They inspected these homes and then published before and after photos to show worker compliance with the company's rules. Ford felt that this was his duty. He hated the trends that he was seeing in industrial society. Ford viewed immigrants, especially Jewish immigrants, and the corporations that employed them as serious threats to democracy. In the late 1920s and 30s, Ford turned to focus on his social goals. He wanted Americans to learn not from the school books, but from life. So he opened a museum dedicated to Thomas Edison, and then another one all about Ford Motor. Ford went really overboard. He relocated the homes or workshops of famous inventors and recreated others, organizing them into a whole town called Greenfield Village with no regard for geographic accuracy. See, Mayfield is a mishmash paradise for a historian of technology. To this day, you can visit Edison's Menlo Park Laboratory and Wright Brothers Bicycle Shop and George Washington Carver's house. Ford Motor kept operating his museums in Greenfield Village after he died, updating the museums to showcase all kinds of innovations. What were the short-term effects of scaling up the auto industry? Well, this also meant scaling up the infrastructure of roads, gas stations, and mechanic shops that could keep motorists a motoring. Cars also increased access to national parks. More people were moving to cities, and the U.S. government was starting to protect wild spaces from development. Cars allowed people in cities to get out to these spaces, generating new interest in nature with a capital N. This led to research on the scientific management of forests and influenced the young discipline of ecology, which we'll get to in a later episode. In terms of economics, other car manufacturers emulated the Fordist assembly line method. While Ford concentrated on producing as many Model Ts as possible, General Motors created many different models, giving Americans more options. By the middle of the century, only three companies, the big three, Ford, GM, and Chrysler, dominated the American auto market, pushing out small regional manufacturers. And Ford's company became a symbol for the transformative power of American industry and for the tensions between the owners of large corporations and the workers running. Industrialists felt that their workers had freedom as non-unionized contractors, and that large corporations were a natural result of innovation. Workers, on the other hand, didn't feel free. They worked long hours and often had little choice, as with Ford Motor, to where, even how they lived. They came together, forming unions in order to negotiate for better labor conditions. Finally, scientists and engineers professionalized a lot over the course of the 1800s. The American Medical Association, for example, was founded in 1847, and Wyoming became the first state to legally license engineers in 1907. Increasingly, being a doctor or engineer wasn't something you could just do. You needed university training, financial backing, and professional licensing. And corporations such as the Edison companies and Ford Motor offered paths for professionals to follow, shaping what it was that scientists and engineers did all day and why they did those things. Today, many people claim there has been a third industrial revolution tied to digital information technologies, and even the fourth, the current one, tied to internet technology. Before we get to those stories, however, we have an entire 20th century to get through. Next time, bust out your old records. It's the birth of math media. Congratulations for your time to film the Dr. Cheryl C. Kinney studio with us in Real 10 minutes. Maybe.
I don't know why this place always talks very fast. And now we come to the period of classical control from 1935 and 1950. And a scientist named Norbert Wiener in 1948. He wrote the book Cybernetics and laid the foundation of the control engineering. So we call it the father of control, maybe. And he gave us the description of feedback control, which is what we learned. And by Norbert Wiener, founder of the cybernetics sector, feedback is the method of controlling a system by inserting into it the results of its past performance. How to understand this? Because this is the what typical block diagram for a feedback control system. So the feedback is what? How to make actual output back to what? Back to the desired site and make the difference. So we can call it inserting into it. And this we can call it past performance, right? Just maybe several steps before. So feedback is a method of controlling the system by inserting into it the result of its past performance. And start from 1950, we come to the modern control period. And first artificial earth supply. How to pronounce this? Maybe it's in Russia, no, Soviet Union invented. This how to it's English.
No.
Oh, okay. Yeah, so what's the meaning of this? just name.
Maybe just name.
Just name has no meaning.
I think it has a meaning.
Okay.
There's
And the most of one. Most of one. Launch the moment. This is the future. And still invented by Soviet Union. And this is very famous and still have debate on whether it is true or not. What do you think? American landed the Apollo on the moon, so we still debate
Yeah.
it is true or not. What do you think?
I think they.
Space. And this is a picture showing Apollo 11 launch moment. And
The debate is about their claim.
oh,
Employee. True.
it's true. Okay, you can have different opinions. Yeah, this is not have a business of this course, so you can whatever. But at front now I have back down from the spaceship. Eagle, and he became the first human, although we don't know it's really the first one, still the one. To set foot on the moon, and he said, and actually it's a very famous sentence. You guys know that? This is one little step for man, but a very large leap for human. This is the famous sentence that he said. I don't know, sure. And Mars exploration was very, it's made by USA. Okay. Here are some exercise. For what?
I want to know your views.
My
Apologies.
Apollo. I don't know, because Chinese we Chinese send send aircraft the space aircraft to the moon, no one in that ship. Right? So maybe from that first stage, technology could not be the requirement to send a man to the moon. Yeah, some secret technology we still don't know, maybe.
But that's why. Why land? Why?
It's like the space galactic competition between USA and Soviet Union at that moment.
Yes, but like I'm saying, why? Like okay, if you have
They are arguing about who is the number one country in this verse, maybe yet. But it did improve the improvements of the whole technology. So my studying it's just SMS course because I went to US for my master's degree. So that's where I practiced my oral English and the English thing. And my university located in Chicago. Chicago. And Illinois Institute of Technology, Armor College. And I majored in aerospace and mechanical engineering. And I'm the only yellow girl. I don't have that kind of friends from the same country, so it's still lonely during that days. And my lecturer, some of the course the lecturers come from India, and they have very strong accent speaking English. So for me to to get into the accent and to know what exactly she was talking about, and as I feel so lonely, but I just say I need to get some offers from the lab. So I talked to the lecturers, professor, so I can do things for free. Let me into our lab. What the modern technology is right here, but one lab is about navigation, but it has a cooperation relationship with NASA. So now USA citizens can get into that lab, yeah, they have strict the rules for them. So I get into one lab and it's all about robots. But still interesting, and we dinner every week and talk about what is the most progress we made and the papers that published. So kind of interesting. So those days, I really miss those days. After I got to China, I never had the chance to go back to there. But I think like studying abroad is a very good experience for me, and I think it's a very special experience for you guys too. So just cherish what you have now, because a lot of people can still at their home and they cannot like your guys sitting here and listen to the lectures face to face. So I think it's a more efficient way to give lectures and learn things face to face. Online course is just it's really a challenge for me during the coronavirus situation that we years ago. I mean, that is 5 years ago. So I taught class during internet, and I don't know, the students over the internet in there. It's really sitting there. Because through the screen, I have a lot of screens, small screens children, like the 15 or 16 or more of them there. And I don't even there sitting in front of their campus. I would not know I need to pay attention to what I'm talking about. I don't have the patience to pay attention to other things. So I think like teaching according to our through internet is a very efficient way. So I don't know, I still don't know how to. I can give you assignments and you can hand me homework, right? And we can have discussions. But how the students over the internet there? I have no ideas, and it's hard to give you guys the same test. Maybe I need to arrange 2 tests. One is for you in class, and another is for them on internet, right? So, let's talk about still get finished this. Talk too much about that things. So just say it out. What do you think for each one? First one, open loop system and closed loop system with the same section components conditions. They are has same precision components. Which type of system has much higher? I think those.
Opens.
Think it over. Think it over and over. Because it has like feedback. So we can minimize error step by step. So I'm going to consider that they have the same precision components. Closed loop has much higher errors. And the second one, which type of system output system has an input on control function? Control function means the blocks, each blocks.
No.
That open impact back.
No.
How to have an impact on those blocks? Should have feedback.
Yes.
So
Close
close those systems. Which type of system is more resistant to interference? Disturbance. Okay. Really?
To check.
And if we have open the now, and it doesn't meet our requirements. And because interference or disturbance has a bad effect on it, but we can do nothing. So we can manually change, but automatically do nothing. But if there is another instrument that is closed loop and it has a disturbance that affects, but through the feedback, one step as time goes, the affection caused by the disturbance can be eliminated. D. So good. So you can which one to eliminate affection, bad affection caused by disturbance? Close. Because open system cannot just wrong. He doesn't care about whether you build a final. It just goes according to the level you settle or the set point you settle. This data, which is the access to ensure learning satisfaction. Which one? Which ability is most important? Most important. Basis. It's the basis. Once the system is stable, then next we will consider about the accuracy or response speed or other abilities. But stability is the first ability we think about to design a system. So stability. So here we have we will have homework. And the assignment for check one, you guys have the book, the PPT, but the homework is and the textbook.
Digital.
Oh, you mean I scan this and upload it? Because the homework is in textbook.
Acho que não.
Maybe I scan it before I need to search my computer to see. Okay,
Já. Não, acho que
Yeah, read the book for you, right?
Yeah. Yes, but if the sharing is fast, they still need a bit. So they
Yeah, of course. I scan before, but keep it to search my. If I have see, so the sign for chapter one is the real problems from page 70. No. Oh, I write the answer here, so I cannot show you the how really maybe I will find the scan version and upload. We're not yet.
Yes, you just someone. That's 5 seconds.
We can talk about sound like the study of growth life in Chicago.
Yes.
Are you interested in it?
Yes.
Chicago very strong in both. And when I was in Chicago, yes, some popular player at that time.
Beautiful.
Rose.
Who's?
Rose. Rose.
The guy I know like it.
And that's
But at that time.
the most popular player is Rose in Chicago.
But I like it.
And he was not injured at that time. It's very so he was very, offensive and the better of the players' shirts, not the white shirts. Rose and everyone sitting and the zero. Yes, I'm not so very much fond of NBA, but I still bought like 3 times tickets for to see the that. I'm not Chicago to see it. Yeah. So you can very interesting.
How like because you watch it on the screen and you sometimes you see the play very small, but they're very tall.
I don't know that much clear about the basketball rules. I just didn't know how to slow down for
I think when you reach the screen.
yeah, that's totally the atmosphere.
Yeah.
And being there and even though I'm just go there by myself and friends with me, but sitting there and the local thing that you will talk to
Yeah.
friendly and talk to you. Though I don't know what he's totally talking about. I don't know much about people, but I'm still talking back. Like we are good friends. Yeah. And still don't know what he's talking about. And there is one game at that time that like the Bulls versus my own kids. Yeah. And at that time, who is in it? James, James, and Wade. Yeah, Wade and James. At that time, we're in kids, and the kid comes to Chicago to play the match with and the price for that is very high. And I went there and but at that time I don't know it's really the James was injured or not. It's not lined up. Yeah, and old gentleman came later and he went to see if James lined up. No, and he's talking about some bad words about James.
How tall the players?
What? The players.
They're very tall.
No, the price I can the see is very far from the playground, so I just can't see not very clear. I'm here to have this experience to see the shells, to see the game.
I just want to see a 7-foot. So I've never seen a 7-foot. I want to see how because I had a 7-foot that way. And so 7-foot.
And in Chicago, it's a city that likes sports very much. But besides sports, they have like the baseball team, Sox, White Sox,
Yeah.
White Sox, and have like the football team or soccer team. Yeah, American. I don't know.
Why?
I don't know. I'm not appreciate it. I don't know. Either the game is very interesting or not. It's not interesting for me, so I never go.
Maybe you should read the rules.
But the professor who taught us engineering math, he was so into it. Yes. The next Monday, sometimes once he's teaching us, he will always like spend half an hour talk about the black divisions match of the soccer game, and I don't know what he's talking about. That. And I think that's interesting. For me and for you, I said there's 8 hour lab hours, right? 8 hours lab, and you're not you didn't use MATLAB before. MATLAB.
You know it's probably
Oh, okay. See from the name, tell me what do you think about this software? MATLAB. Its original purpose when it's invented is to solve the matrix problem. Matrix. So it's originally maybe it's matrix lab, something like that. Show it MATLAB and do some simulation.
Yeah. You really need it in this course.
Yeah, because we will use MATLAB in our lab. in our lab during our lab hours, in 8 hours.
So you teach us?
Yes,
Oh, very good.
you need someone else to teach you math lab. So
The reason is sometimes our teachers teach each other.
Yeah, we're not
Not the same one who teach other. So
but here's not the problem. I need to find a lab that has lots of computers and their computers must be set up the math lab. And I don't know if I can find a lab, but you guys are all lectures, right? Maybe you can install math lab on your laptop and take a laptop to this classroom and I can teach you in this classroom.
Actually, I use the desktop.
Maybe you actually have to run.
Yes, actually, you can do that. You can use that.
Yes.
But how about the students over internet?
Actually, this is.
Actually, maybe it's better if you can install one of these computers. Then the teacher can go to the lab.
But actually you should do it yourself.
Promises.
Do the
Yeah.
code, do the debug yourself.
Yeah.
You know, the lab is just only by teaching. You should experience yourself.
Actually, it's a mechanical lab. There are.
That computers has that level.
I think it's fine. We went there last year. We used solid
Shooting
the mechanical lab.
mechanical.
Yeah, completely sorry. We are going to shoot the same
For this year.
Okay, maybe I can talk to administration if they can rent the lab.
Don't we need machine?
because the computer labs.
Yes. And this is a not a free software. It costs a lot. So we use the version, you know. But the thing is different as you cannot use the card. And you cannot press because it's illegal. And why?
It is illegal, but you can. But it's illegal. But it's like it's you can, but it's illegal. If they catch you, you're
Yeah.
But who touched you?
But the only yellow girl in my class, yeah, I'm afraid to do something illegal. Not that I can do that, so I didn't do that. So at the time I wanted to go back, came to the lab, to the robot lab. They have computers there, and we do simulations on their computers. It's not convenient.
Yeah.
In China, you can use factors. This is very expensive. Personal version, MATLAB costs you like maybe thousands renminbi. This price is very.
That's too expensive.
So we use factor version. But instead of this, we have a replacement free. This software named SDI Lab. It's free. It's free. You can download on their on their website. It's free, and it has the same function with MATLAB. You can search SDI Lab and download it, and the things are the same.
Yes.
Okay, I want to talk about this homework. It's if you don't have those, and you don't know how to write. So I want to talk about problem in class. Sure. You're not good at drawing.
Actually, we have someone who's very good at economics.
Really? Can you try it for me?
He doesn't take money to.
She's not doing it. I'm really, she's letting me.
I've never seen I can't see the answer.
Like you walk.
Yeah, I've seen the answers on my screen.
Forget it. Forget it.
Actually, I just can't forget. I can't tell on my screen.
I think it's going to draw you.
Don't get that. Take that in that next.
You think that is a group?
Don't take that in that. You should give to them. Now, but you are good to know, you know.
I'm more
Just
than good.
figure.
So you must call it.
Oh,
Let me see it.
you already finished other courses this semester?
I use one.
Yeah.
Oh, shit, good.
But I and both.
Yeah, we can see it.
But it's been a long time to talk so much in English. Because back in China, there's seldom the situation.
Yeah, there is no.
Some kind of conference.
Maybe from home you can find.
So,
For me to attend some conference, international conference, and I went to some conference. I need to give them presentation about my paper, about my research work. So I use English. It's seldom, so this is a good time for me to practice English.
so what food were you eating? Did you get some food? Life is not nice. The shima.
There's sophomores in college. Sophomore?
Someone has seen.
Yes. Okay. This short little line means water. Okay, in case you don't understand when it's starting.
Sound of government arguments.
So you can use some.
Yes.
Yes.
Why you didn't open the box?
So what you would like to provide?
Go back to
Then,
1 second.
you're done with that. Like if you continue like PhD or something.
Oh, Apple.
So what do I going to go back?
Why should I go back? Good place to work.
So no, I need to go back.
Yeah, the coronavirus situation here can control, but the teacher cannot control overseas. It's safe here.
Well, I guess I'm student doing a full time. And that's
As long as you remember.
really.
Maybe every time you start to write your homework and you forget what you learned.
Sometimes okay. Sometimes
Listen.
Okay, thank you. Just well. So let's see. Here is the figure you need to deal with.
Guys, please.
we will have a discussion about this figure because this figure is the problem you need to deal with in your homework one. And here, water level control system. And this is water. And we have two valves. One is valve one. The water will go through the valve and fill in the tank. It's valve two. And water will go through the valve. And we have a lever here, and the lever is linked to a boil. Boil. Boil.
This what do you
Boil. It's a ball, but it's has a function to measure the water level. It's no. And here, can you describe how does this whole system work? How does this system work? The target we want to control, we want to keep is the value, which we want to the level of the water keeps in a constant value. Maybe our target value, you can set it. You can have a set point. And how does the system work to keep the target water level? Can you tell?
So what are we saying about the inlet?
Here,
Yeah, what are we the inlet?
water goes through it.
Through the inlet.
And you forget to draw the link.
Oh,
The link between the valve and the lever.
so that's now because the link really now explain. Yeah, the
So how does it work?
how the link is
this way is like keyboard, right?
so level
This
words
this boil plays the role of what? Plays the role of what?
Just like
Sensor.
yeah
Sensor.
taking the level
Sensor. See? If we want the target level is here, right? If now the water is not this doesn't meet the level, a little bit lower, and the boil goes down, right?
Yeah.
And when it goes down,
Yeah.
the link between the lever and the valve will make the valve what? Open.
yes
And the water fills in.
Yeah.
And when the water fills into the level of the target value once,
Okay.
the boil,
Then it's make it jam.
yeah, the boil will goes up, and and then this will what? This ball will goes up and be closed, right?
yes
And the filling process will be end, will stop. And what's the level right now? Just meet what? The desired or the target value. Is this the whole thing working? How does this system work? But I still leave a problem about what is the function of valve 2.
how to means when the water level is higher than expected than one.
So you treat this or
And
what's wrong?
Check the maximum level or
This is
Oh no. To consider valve 2 and valve 1 together.
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 yes
Think about the elevator problem. The 15th floor, we consider 15th floor disturbance. So this has affection, but this affection is the affection we want or we don't want. We don't want, right? We just want to control one valve to meet our requirement. But still, we have another affection from valve 2. So in this case, we treat valve 2 as what? Disturbance. Just the affection we can control. So we treat it as what? Disturbance. So the homework 1.5 in page 17 says you should build a schematic block diagram for the system show. So the whole block diagram, you will draw the feedback loop, right? And don't forget the disturbance. So which part you should put the disturbance in? Which part? Like we have sensor, actuator, control project, right? So which part you should put the disturbance in?
Go back and we will see which part.
Which part? Yeah, which part you should draw the disturbance in? Forget. Okay, we can go back to see the typical diagram. I said before, you should memorize it. See? Put disturbance in which part? Upon control of disturbance here. So in this case, you write low 2 instead of disturbance, right?
Yes.
And you write each part name instead of which part. You find which part and you write that, right? Then you finish the whole diagram. So that is what homework 1.5. Okay, I see today's okay. Still have problems?
No.
So have any suggestions or have some other?
Yeah, like now she also.
I think it's very good.
You were a student, and if now she see there is some necessary things we have to learn. This is the most important we want.
We enjoy the love of motion.
You know how practical is so important.
The practical physics when things done. And thank you very much. I think that I don't have any problem. I think the class is just as it should. Thank you very much.
Okay. If any problem, just talk to me. And I think if you think my oral English is not good enough, then as the time goes, as the lecturers talk one by one, I think I will improve my oral English one by one. Because I already,
No, to be honest,
Honestly.
Alaushi, can you send us the PPT files?
but I can. Okay, the students over there, we finished our course today. Oh,
Asking for attendance.
and the homework, someone will upload the homework for you.
Yeah, I
Okay, okay, someone will upload the homework for you and you finish the homework. Oh, I forgot to say, hand in your homework every 2 chapters.
yeah.
Hand in your homework every 2 chapters.
Okay.
Together, yeah, together.
Okay.
Okay, Alaushi.
Okay, so bye, see you guys.
Bye, Alaushi.
If you have any problems, just talk to me through WeChat or
We can send you invitation.
okay.
We can. I'm asking.
Yeah.
We can.